So here we have a system of equation Ax is equal to b. If it has solution, then it is said to be consistent. If it has no solution, it is said to be inconsistent. For a two unknown system of equation, a1x plus b1y is equal to c1, a2x plus b2y is equal to c2. If a1 by a2 is not equal to b1 by b2, then the system of equation is non-singular, and in this case, it is non-singular. And for non-singular system of equation, the solution is unique. Always it will have unique solution. And if a1 by a2 is equal to b1 by b2, then the system of equation is singular, and it has either two options. Either it has no solution or infinitely many solutions. If this ratio is also equal to c1 by c2, it has infinitely many solutions. And if the ratio is not equal to c1 by c2, then it has no solution. Now consider the system of equation a11x1 plus a12x2 plus and so on. a1n xn is equal to b1. a21x1 plus a22x2 plus a2n xn is equal to b2. Similarly, am1x1 plus am2x2 and so on up to amn xn is equal to bn. So here the column form representation of the system of equation is this one. Here every variable is having a coefficient of vector, that is first variable a1, second variable coefficient vector is a2 and so on. So if we can write any system of equation in this format, in short form it is a1 x1 plus a2 x2 and so on. Plus an xn is equal to bn. B vector, this RHS vector is b. That means what? If I have some scalars x1, x2 and xn, if I have a system of equation, this system of equation has solution, that means I have some scalars such that b is equal to a scalar multiple of a1 plus another scalar multiple of a2 plus and so on up to another scalar multiple of an. That means b is a linear combination of columns of A. B is a linear combination of columns of A implies B belongs to C of A. So what we have concluded? If any system of equation has solution, then its RHS vector belongs to column space of A. Similarly, let us assume that this system of equation is having, in the system of equation, B belongs to column space of A. Observe here. If B belongs to column space of A, that means I can get some scalars C1, C2, C3 and so on, such that B is equal to C1 A1 plus C2 A2 and so on up to Cn An. That means B is a linear combination. If B is a linear combination of columns of A, then B can be written in this format, where all these C1, C2 up to Cn are not simultaneously 0. But the question is, if I can write B belongs to this, that means B belongs to C of A, that means B is a linear combination of columns of A. That means I can get some C1, C2, C3 such that B is equal to this, which I can write it as x1 a1 plus x2 a2 and so on up to xn an. So what we got? That means x1 x is equal to x1 x2 and so on xn is equal to is equal to C1, C2 and so on up to Cn. So what we got? The system of equation has a solution. So 2 has solution if and only if B belongs to column space of A. It is one of the significant property of any system of equation. It has solution only when the RHS vector is a linear combination of columns of A. Now, when it will have unique solution, when it will have no solution. If the coefficient matrix A has full set of pivots, if it has full set of pivots, then A is non-singular. In that case, this implies Ax is equal to B has unique solution. Okay, so now let us study further. Okay, these are some basic aspects. Suppose a system of equation is given in the examination where it is a 3 cross 3 matrix. This is a 3 cross 3 matrix. One of the coefficient is made D, G, B, K something, and here one of the coefficient of B is made C, K, L, J. Then it will be asked that for what value of the in the coefficient matrix, the constant in the coefficient matrix, the system of equation is singular. That means or non-singular. That means we will verify for what value the system of equation has full set of pivots. If it is has full set of pivots, it is non-singular. If it has missing pivot, then it is singular. So echelon form is the best form in this case. Okay. So now let us discuss some of the. It is one of the significant aspects. With this information, at least 3 to 4 questions in different competitive exams, it can be solved with this information. Now we will discuss about some questions or doubts that are being asked by some of the students or viewers of this channel. Okay, question number 4 or 5, something like that they have written. Okay, before that question is available, let me discuss something else. So what is the question? The question is, evaluate the values of D for which the system of equations has a unique solution. Here a system of equation is given. Find out the value of D for which it has unique solution. The question is x plus y plus 2z is equal to 1, x plus 2y plus 3z is equal to 2, x plus 4y plus dz, 2dz, x plus 4y plus 2dz is equal to 1. This system of equation is given. Evaluate the values of D for which the system of equations has unique solution. Value means 1 or more. It is given. So to solve the same type of question, okay, it is one of the viewers' doubts. So let us discuss the same type. First step we will take is we will write the corresponding coefficient matrix, augment matrix. 1. Also, augment matrix is not necessary. Only if the left hand side, because it is asking unique solution, that means we will verify whether the coefficient matrix is singular or not. The question is, this system of equation has unique solution. When it will have unique solution, for what value of d it has unique solution. That means the system of equations should be non-singular. It should have full set of pivots. So only coefficient matrix is sufficient. We know there is no need to write down the augment matrix. So 1, 1, 2, 1, 2, 3, 1, 4, 2d. This is the system of equation. Okay, it is A equal to. Now it is similar to what operation I will do? R2 minus R1 stored in R2, R3 minus R1 stored in R3, because I want to get the echelon form. So this position and this position, they should be eliminated. So what is the resultant vector? 1, 1, 2 matrix, resultant matrix. 0, 2 minus 1 is 1, 3 minus 1 is 1. And from here it is 0, it is 3, it is 2d minus 2, 2d minus 2. Now this is my second pivot, it is my first pivot, below it I have made 0. Now it is my second pivot, below it I should make 0. What operation I should do? R3 minus 3R2 stored in R3. One thing we must know, that whenever in any column I am eliminating any variable, then the corresponding pivot of that column must be used. If I want to do any change in the second column, I should use the 2, 2 position element. If I want to do any change in the third column, I should use the 3, 3 position element. Okay. So now my target is to make it 0. So how to make it 0? If I will subtract thrice of the second row from the third row, I will, and the resultant I will store in the third row, then I will get it. So let us do 1, 1, 2, 0, 1, 1, 0, 0, 3 into this. So how much? 2d minus 5. Now when it will have full set of pivot, this is a pivot, this is a pivot, and this is a pivot. Whether it last pivot will be missing, for what value of d last pivot will be missing? I am expecting the answer from the audience. Please explain. Just answer. No need to explain. Just tell me, for what value of d the last pivot will be existing. It will not vanish.
2d minus 5 is not equal to 0.
Thank you. So 2d minus 5 not equal to 0 implies A has full set of pivot. Hence unique solution. Hence for D not equal to pi by 2, A has unique solution. Sorry, A has the system has unique solution. Okay, how many D's? How many D's are there? Unique solution. Okay, how many D's? Infinitely many. That is D is equal to D belongs to the set of real number minus the singleton set pi by 2. For every value this, we have our D, any real number not equal to 5 by 2, we will have the system of equation has unique solution. Is it clear to all? Is it clear to all?
Yes, ma'am.
Either tell yes or tell your doubts. Should I proceed to the next question?
Yes, ma'am. Yes, ma'am.
Okay. Another question is given for B. Some question they have sent. Find a basis for the plane x plus y plus z is equal to 0 in R cube. Okay. It is another question. We are expected to find out a basis for x plus y plus z is equal to 0. Find a basis. This is the question. In RQ, of course, because three variables are there, means it is in RQ. Then find a basis for the intersection of that plane with the YZ plane. Okay, first of all, its basis we will find out. Also, find a basis. Suppose its name is P. Find a basis for P intersection with YZ plane. Okay, YZ plane means what? There the x component will be 0. Okay, so first of all we will find out the basis. Find out a basis. There one of the basis vector, the basis vectors having x component 0 will be giving us the second basis. Okay, how to find out here? Here we will see how many free variables are there. We have three variables, out of which x, y, z. Here this is free variable, this is free variable, but this variable I cannot write as per my wish, because once I have decided y and z value, my x value gets fixed. It is pivot, so it is restricted variable. So I have one restricted variable x and two free variables y and z. Here one value I will put. I can arbitrarily give any value to y and z. But to make the task comfortable, I will assign one of the free variable as 1, another is 0. Similarly, I will assign here 1, 0, here 1, and I will find out the corresponding value of x. It is also minus 1, it is also minus 1. So hence, a basis for the given plane is, what's the basis? P1 is equal to, why I have written P1? Because second one I will write again, is equal to minus 1, 1, 0. Another is minus 1, 0, 1. So we got two basis vectors. They constitute the basis. Now the second part of the question is, this is my plane, the vectors constituting my plane. What about the plane when it is intersected, basis of the plane intersected with YZ plane? YZ plane means what? Okay, here I will not make my x variable free. Observe here. I cannot make here my x variable free, because x variable is taking value 0. It is already fixed. So I will make here a small change. What the change I will do? Any two variables are free variable, na? So I will change my free variables. I will make my z axis restricted variable, and my x-axis free variable, because x-axis should take value 0. So this is my free variable, this is my free variable, this is my restricted variable. Okay, or restricted variable. So here I will give, first I have given here 1, here 0, then here 1, here 0. What about the value? It is -1, this is -1. So what about the basis? Basis will be this is 0, 1, -1, -1, 1. Okay, this is second one is -1, 1. Now tell me, out of these two vectors, which vector will be having x component 0? So what will be the basis for yz plane? The vectors in the basis B1 having x component 0 form a basis for what plane? P intersection yz plane. So what is the basis for this? Hence, what are the vectors in the basis? For which vectors constitute? Its x component is 0. In which vector the x component is 0? Hence, a basis for plane intersection with yz plane is how much? What will be the answer? B2 is equal to 0, 1, -1. Is it clear to all? Is it clear to all?
Yes, ma'am.
Yes,
Should
ma'am.
I proceed to the next question?
Yes, ma'am.
Pancha number. फाइव सी कहते ना बी कह के जानी जस्ट a second kindly discuss bit 4 5c 5c okay, two vectors are given, two matrices are given. What's the relation between their determinant? This is the question. Let me read the question clearly. Determine the relation between the determinants of A and determinant of B, where A is okay. The color to change kar. So here what is given? It's a very easy question, but relation between determinant of A and determinant of B. This is the question. Where what about A and B? A is 1, 2, 3, 4. 1, 2, 3, 4. 4, 1, 2, 3. 3, 4. 1, 2. 2, 3, 4, 1. This is given as A, and B is equal to, probably this is a previous best question. I think so. I don't know. 1 2 4 1 2 3 1 2 3 4 2 3 4 1. Okay, what is the relation between these two? This is the question. The determinant of these two matrices, what is the relation? Now let us observe thoroughly. If I interchange these two rows I of A, then I get the matrix B, nothing else. Observe this row is same as this row, and this row is same as this row. So what is expected? Only change it is in between, and we know if two rows are interchanged, B is equal to E, how much concepts? 1 and 3 of A. So if one row interchanged takes place, so that means how I will get my B? R1 interchange with R3 on A of A. So what's the relation between, if two rows are interchanged in the determinant of, then what is the relation between the determinant? This implies determinant of B is equal to minus times determinant of A. Is it clear to all? Is it clear to all?
Yes, ma'am.
So is there any other question as doubt? If you have any question, then please ask, or else I will tell you some tricks. Okay, let me tell you, suppose you have a vector. How to verify whether it is an eigenvector or not? Okay, suppose you have a vector, you want to verify whether it is an eigenvector or not. So what to do? A is given a matrix, a given matrix A is given, X is given. If you are multiplying, suppose I am giving a matrix 1, minus 1, 2, 4. Okay, I want to verify 1 minus 1 is a vector, eigenvector of this matrix or not. It is an eigenvector of this matrix or not. So what I will do, I will multiply them. Then what I will get? Observe here. 1 into 1 and minus 1, so it is 2. And here 2 minus 1, minus 2. So what I got? It is 2 times of the given vector. If any vector after multiplication gives a scalar multiple of itself, then that non-zero vector is an eigenvector. Okay, if any non-zero vector X gives AX is equal to CX, then X is an eigenvector of A. Now tell me, just observe this. I have given you one information that, let us assume, here I have proved that this is an eigenvector for this matrix, because when this matrix is multiplied with this eigenvector, I am getting twice the given vector. Now tell me, what are the eigenvalues of this matrix? With this information, tell me whatever the eigenvalues of this given matrix. Yes, please. Here, how to find out the eigenvalue? Observe here, it is a trick. Here, this is my one of my eigenvalue. This is one of my eigenvalue. What about one eigenvalue? What's the eigenvalue? Without doing any calculation, directly from this observation, I can obtain my eigenvalue. What is it? That? Yes,
M2.
please.
M2.
It is 2. Now tell me what about the other eigenvalue? Without calculation, directly you are expected to answer it immediately. What about the other eigenvalue?
मैम आइगन वैल्यू का प्रॉपर्टी लगा सकते हैं.
हाँ, प्रॉपर्टी लगाकर बताइए क्या होगा?
मैम प्रिंसिपल डायगोनल
Three,
को
yes.
ऐड करके
The trace of the matrix is sum of the eigenvalues. So what about trace of A? Is equal to 5 and lambda 1 is equal to 2. This is equal to lambda 1 plus lambda 2. What about lambda 2? This is 5 minus 2, that is 3. Okay, without calculating, without doing any calculation, directly I have verified, I have obtained my another eigenvalue. It is one of the significant property. Next. ଆଉ କ'ଣ question ଅଛି କି doubt? Suppose somebody will ask me a matrix A has A is given. Suppose in the exam, maybe in some get exam, net exam somewhere, A is given. Okay, and you are given with one eigenvector also. Okay, V1 is given. You are expected to answer, find out the other eigenvalues. So what you will do? As it is GATE exam, you will multiply every vector, then you will find out. Suppose I have A, B, C, D. This is my, but this is my matrix A. Suppose this is my matrix A. Now V1 is given. V1 is equal to EF. This is given. Okay, you are being asked the other eigenvalue, the eigenvalues of A. Find the eigenvalues of A. As it is competitive exam, so it is given, what is given? V1 is an eigenvector of A. It is given, and V is given, A is given. Find the eigenvalues of A. What will you do? So you will verify, observe here, A into E plus B into F. This is how much times of E. A into E plus B into F gives me how much times of E. That is one of my eigenvalue, lambda 1. How to find out the other eigenvalue? A plus B minus lambda 1 or minus C. Are you getting? Here, yes. Lambda 1 is equal to how much? This is my lambda 1. So what is my lambda 1? Lambda 1 is equal to C. So what about my lambda 2? Is it clear?
Yes, ma'am.
Is it useful? There is no need to write down, find out each and every component. Suppose it is a n cross n matrix. No, please. Class. Online class. So here, if I have, suppose I have n cross n matrix. A is a 10 cross 10 matrix and V vector is having 10 components. Still, I need not verify every component. I need not multiply the total vector because it is given that V1 is an eigenvector of A. Immediately, we will just calculate the first component, and first component of V1, how much scalar is multiplied to get the result. यहाँ पर ये जो है ये ओनली फर्स्ट कंपोनेंट को मैंने ऑब्टेन किया है. ये रिजल्टेंट वेक्टर का फर्स्ट कंपोनेंट ये होगा एंड ओरिजिनल वेक्टर का फर्स्ट कंपोनेंट ये है. तो इसको इस कंपोनेंट को कितना मल्टीप्लाई करने पर ये कंपोनेंट मिलता है उतना बस देखना है. मिल गया तो जितना मल्टीप्लाई करने पर होता है वो है आपका सी. फॉर एग्जाम्पल आप एक मैट्रिक्स बताइए मुझे, मैं ही लिख लेती हूँ. 1 2 3 नॉन मैट्रिक्स चले दो 1 2 1 1 2 1 1 1 2 2 1 2 1 1 2 1 2 1 2 1 1 1 2. This is a matrix. Okay, in this case we'll find out the, suppose we are given one of the eigenvector. Suppose I have an eigenvector A, B, C. Okay, here A is this. Here I have made my A variable. Yes, what happens? Still now some complaints are there. Anything, any complaint? Whether my Google Meet is continuing, na?
Yes, ma'am.
Okay. Okay, so here I want to verify my eigenvalues. At least one of the eigenvalues. Suppose here it is asked that this is an eigenvector for this matrix. Okay, find an eigenvalue of A. Okay, this is X. X is an eigenvector of A and find an eigenvalue of A. This is being asked. Okay, so what I will do? I will just multiply. How much? 2A plus B plus C. This is a scalar value. This scalar is equal to K times A. This K is one of my eigenvalue. Okay, is it clear to all? If it is a 2 cross 2 matrix, okay, let us verify. Here I need not verify each component. Just one component I will verify. Okay, is it clear? What are the eigenvalues of this matrix? First of all, I hope all of you know that one line formula for the characteristic equation. CH equation for A is lambda square minus 4 lambda plus 3 is equal to 0. So what are the eigenvalues here? Eigenvalues are 1 and 3, 3 and 1. Okay. Now what about the eigenvector? Suppose it is, let me substitute 3. In case of 3 it is 1 1. Okay. When I substitute 3 it is 2 minus 3 1 1 2 minus 3, that is minus 1 1 1 minus 1, that is here first component and second component, they are of same value. X1 is equal to x2. So what about the matrix? It's a vector. So 1 1 is an eigenvector for this matrix. Similarly, now I have got 1 1. Okay, let us assume that nothing is known to me. Okay, all these things are not known to me. Only this is my given matrix. Okay, tell yes sometimes to encourage the speaker. So this is my given matrix. Let 1 1 be a eigenvector of A. Okay, this is given. Find the eigenvalues of A. So what should you do? Now in this case, I have given you one matrix and one eigenvector. So how to find out the eigenvalues? What should I do? As I have told, the first row will be multiplied with the factor. I will get 2 into 1 plus 1 into 1 is equal to 3, which is equal to 3 times this first component. So one of the eigenvalue is lambda is 3. Lambda 1 is 3. Now what is lambda 2? 2 plus 2 minus 3. That is another value is 1. Is it clear to all? Is it clear to all?
Yes, ma'am.
Next, you can clarify. You ask your doubts. Echelon form, elementary row operations. There we have some people used to get confused. There I will tell about elementary row operations. What are they and why they are being used? Then we will go for further. Elementary matrices and elementary row operations. Consider 1 0 0 0 1 0 0 0 1. This is identity matrix I. After applying one elementary row operations, there are three types of elementary row operation. One is Ri plus Krj stored in Ri. Another is Ri interchanged with Rj. Another is C times Ri stored in Ri. There are three types. Okay. So suppose here type 1, type 2, type 3, all three types of elementary matrices we will discuss. Suppose I have done R2 minus 5 R1 stored in R2. This operation I have done. So how to get the corresponding elementary matrix? The corresponding elementary matrix is, I will write everything. Every element I will write other than this position, 2 1 position, except 2 1 position, every other component I will write. So how much it is? 1 0 0 1 0 0 0 1. आइडेंटिटी मैट्रिक्स का हर एक कंपोनेंट को लिख दिया, बस 2 1 पोजीशन में नहीं लिखा. 2 1 पोजीशन में कितना लिखना है मुझे? इतना लिखना है. तो कितना लिखना है बताइए ना. -5. So here out any row operation is given. So this row operation is equivalent to this matrix. Whenever any matrix is multiplied to, suppose I have a given matrix A, I will multiply this matrix E on A. I will get this row operation taking place in A. Okay, A में ये ऑपरेशन हो जाएगा. कैसे देखते हैं? कोई एक A बताइए. 1 2 3 5, 3, 1, 4, 2, 7. So here, this is my A. Then tell me what will be my EA. I need not write the complete matrix. This is my E. 1, 0, 0, minus 5, 1, 0, 0, 0, 1. I need not write this, multiply this matrix with this completely. Directly in one step we can write the answer. Only in one row there will be change. So what about that? What should I do? When this matrix is multiplied from left hand side, then row operation takes place. If the matrix is multiplied from right hand side, then column operation takes place. Now tell me, what should I do? What will be the resultant from the audience? Okay. There will be only one change in the second row. Rest all row will remain same. So what I will do? First row I wrote as it is. Third row also I wrote as it is. So in the second row, what should I write? Second row, R2, this operation. This operation will take place in A. That means R2 minus 5R1 stored in R2. It is the 5 minus 5 लिखी जहाँ लिखा है Okay. So इसका R2 minus 5R1 stored in R2. How much? 5 times R1. Subtract from second row. So 5 minus 5, 0. 3 minus 10, minus 7. 1 minus 15, minus 14. All of you got it? Similarly, if this E is multiplied from the right hand side, then column operation takes place. Let us do another operation, our identity matrix. Identity matrix 0, 1, 0, 0, 0, 1. Now let us interchange R1 with R3. What will happen? R1 similar to symbol is expected in the examination. R1 interchange with R3. So what will be the corresponding elementary matrix? E is equal to, just interchange the R1 and R3. 0, 0, 1, 0, 1, 0, 1, 0, 0. This matrix speciality is, whenever it is multiplied to any A, the resultant, this is my A. Here, first and third row will be interchanged. My resultant will be 4, 2, 7, 5, 3, 1, 1, 2, 3. And it is E into A. Okay. So now A into E. This is how much? Observe, this is your identity matrix and this is your E. This is your E. So how much it is? How to get from this matrix to get this matrix? What column operation we should do? Please observe carefully and tell me. Observe, if I interchange first row and third row, first column and third column, I am getting my elementary matrix. So what operation I have to do? Column operation. If I interchange these two columns, then I will get this identity matrix. Same operation will take place here on the matrix. This is given matrix is this one. So what should be our resultant? First column will be written in place of third column. Third column will be written in place of the first column. It is one of the significant thing. Also, while finding LU factorization, we are expected to given matrix. We will do one operation E21. Then we will do E31. Then we will go for E32. means E32. That means first we will apply. So how it is? A on it, first I have applied E21, then I will apply E31 on the resultant. Whatever resultant I have got, there I will apply E32. Finally, it will become an upper triangular matrix. Then, what is my lower triangular matrix? It is reverse order the reverse order. So E21 inverse, E31 inverse, E32 inverse U. So L is, this is, that U will not be there. L, as L is required, so this is nothing but your L into U. So what will be? A is equal to LU. A is equal to LU. So whatever here, its inverse I will write here, then it is my L. So I got my L this. So here also, how to write down the L directly? Observe here, for this elementary matrix, its inverse I want to obtain. Please give some tips for examination. What examination? These are all tips. Observe here, minus 5 is there. It's this matrix, whole matrix inverse can be written as plus. So if I am taking the inverse of any elementary matrix, then just wherever there is a change, there I will change the sign. Suppose my E21 is 1 0 0, L21 1 0 0 0 1. Similarly, E31 is equal to 1 0 0 0 1 0, L31 0 1. And E32 is equal to 1 0 0 0 1 0 0, L32 1. In that case, what will be my L? L is equal to, this is always same for whatever matrix is given. If it is a 3 cross 3 matrix, these 6 elements are fixed. Then in this position I will write this L21 minus, here I will write minus of L31, here write minus of L32. I got my L. Already I have my U. This is my U. Observe here. This is my U. This is my L. So I got A is equal to LU factorization. Suppose again it is LDV. Let me write down U is equal to A, B, C, D, E, F. Upper triangular matrix. So they are zeros. So this is my upper triangular matrix. I want to write down it in the format of DV. How should I write? This is mandatory that in the V all the diagonal elements will be 1. In the D, A, D, F, 0, 0. All the diagonal elements I have taken from U, rest all I have made 0. How to write down V? Every row is divided by the corresponding pivot. So if A is divided by A, D is divided by D, F is divided by F, I will get 1. Then zeros are nothing. Then here B by A, C by A, D by, E by D. This will be your V. Mind it, here LDV factorization, this upper triangular matrix have all diagonal elements 1. And in both LU factorization and LDV factorization, in both case L is having a diagonal elements 1. So these are some of the aspects, very important for examination point of view. Whatever I have covered today, it includes around 20% of the questions. Several questions we have discussed. Further, we will discuss further. So thank you. Probably let me,
Thank
if
you,
you
ma'am.
have any doubt, then please clarify. If you have any doubt, please clarify. No. Okay, sir. Just a second. Sir, asandu, bhitere basandu. Yes, please.
For that LU factorization, I need more clarification about it.
More clarification darkar. Huh? Okay. देखो.
मैम ए अपन केंते फाइंड कला
हाँ? कौन? Base? क्या होती है जोर? Louder. Get louder.
मैम ए
हाँ?
ए
हाँ. अब मैं फिर से स्टेप वाइज बता देती हूँ. स्टेप 1 ए के ऊपर एलिमेंटरी रो ऑपरेशन यूज कीजिए. एलिमेंटरी रो ऑपरेशन यूज कीजिए. कैसे? कौन सा? ताकि 2 1 पोजीशन में 0 हो जाए. पोजीशन में 0 हो जाए. उसके ऊपर ये जो मैट्रिक्स मिला 2 1 पोजीशन में 0, फिर इस मैट्रिक्स के ऊपर फिर से एलिमेंटरी रो ऑपरेशन यूज कीजिए. इसका नाम है E21. अब इसके ऊपर और एक एलिमेंटरी रो ऑपरेशन कीजिए, अप्लाई कीजिए, ताकि 3 1 पोजीशन में 0 मिले. अब ये जो मैट्रिक्स मिला रिजल्टेंट, ए के ऊपर 2 ऑपरेशन कर दिया आपने. एक एग्जांपल बता देती हूँ. 1 1 2 2 5 7 3 1 9 कुछ भी लिख दिया मैंने. ओके, चलते हैं. अब इसका एलयू फैक्टराइजेशन करते हैं. फर्स्ट टारगेट किया है, ये है ए है. दिस इज योर ए. नाउ आई वांट हियर 0. व्हाट ऑपरेशन आई शुड डू? दिस इज R2 minus 2R1 stored in R2. How much it is? 1 1 2 2 3 2R1 3. ओके, इससे दुगना, इसका दुगना, इसका दुगना. चार गलत. नेक्स्ट ये जैसा था वैसे हो गया. अब now on this matrix I will go for another elementary row operation. What is it? I want a 0 here. What should I do? R3 minus 3R1 stored in R3. How much should I get? 1 1 2 0 3 3. It is 0. It is 3 times minus 2. It is how much? 3 times of this. So it is 6. 6 and 9. So it is 3. Okay. Now here again I have to make this 0. So what operation I should do? R3 plus 2 by 3 R2 stored in R3. So what will be my resultant? 1 1 2 0 3 3 0 0 by 3 later 1 ଅଛି, minus 2 ହେଇଛି. So answer plus 2. Plus 2 ମାନେ 2 5. Okay, this is my new matrix which is an upper triangular matrix. Okay, so I got my U. Now what is my L? Observe my L. 1 0 0 1 0 1. This much is common. Now we will write, observe here, what operation? What is my 2 1 matrix? What is my 2 1 matrix position? 2 1 position, it is minus 2. What is my 3 1 position? Minus 3. 3 2 position plus 2 by 3. Okay, these will be my new position elements. So in case of 2 1 position, what should I write? Minus 2. Minus of minus 2. It is minus of minus 2, it is plus 2. It is minus of minus 3, it is plus 3. It is minus of 2 by 3, it is minus 2 by 3. This is my L and this is my U. If it is LU factorization, then A is equal to 1, 0, 0, 2, 1, 0, 3 minus 2 by 3, 1. This is my L and 1, 1, 2, 0, 3, 3, 0, 0, 5. It is my U, L, LU. If it is LDV factorization, then for LDV factorization, LDV. How should I write? It is L as it is 1, 0, 0, 2, 1, 0, 3 minus 2 by 3, 1. L remains as it is. But while writing D, diagonal elements of U, so 3, 5. Rest all elements are remain 0. Diagonal elements of U I have taken. Consider this is L, this is D. Now while writing V, what should I do? 1, 1, 1, 0, 0, 0. This much is common. Okay. Now what I will do? First row is divided by 1. This is first pivot. Every row should be divided by the corresponding pivot. This row and this row will be divided by 5. So how much it is? First row is divided by 1, remains as it is. Second row is divided by 3, it is 1. Third row is divided by 5, it is 1. Already I got it. Okay, LDV. Whether you got it? Somebody told me to repeat this formula, this method. Is it clear to that person? Please tell yes or no. Yes, whether the doubt is clear. Right, tell no or yes.